for nature.
You know what's really neat, Seth?
What?
The natural log.
True.
There's a lot of neat things out here in the nature, and one thing that we find really neat is the natural log. So today we're going to show you how neat the natural log really can be. Sometimes it's a little hard to find the natural logs, so you gotta mix everything up, get the earth moving, and just get it all flowing. Yeah, natural log. Woo, come on. So look, it's a natural log.
Oh my goodness.
Oh, what a beaut.
How do we know that's a natural log though?
So we know it's a natural log because of the way it is.
Oh.
But we'll figure it out anyways.
Okay.
So, for this problem, we're going to be finding the derivative of a natural log. When you're finding the derivative of a natural log, you find the derivative of what's inside of the parentheses, and then you put it over what is the original function within the parentheses. So then, applying that to this problem, we're going to find the derivative of 3x squared minus 7, which, using the power rule, is 6x, and then we're going to put that over the original function, which is 3x squared minus 7. So the final answer is going to be 6x over 3x squared minus 7.
Sometimes when you're looking for natural logs in the wildlife, you'll find wildlife by the natural log. And you gotta stay clear, because they're a little dangerous sometimes, and that's their habitat. So you gotta be like, hey, I think you're pretty neat and all, but I respect your distance.
We're gonna have to come back later for this natural log.
So this problem is a little more complicated. We're going to have to use properties of logarithms. So for the top, the multiplication is going to turn to addition, and then for the bottom, we can subtract that from the top. And then after we do that, we're going to have to take the derivative of each individual piece, and because it's natural logs, we're going to have to do the derivative over original form to find the final answer.
Grandma, look, I think it's a natural log. Oh, by golly, Soph, I think it is. Oh, what a beaut.
So for this problem, we're going to have to integrate a natural log. So we're going to have to do the exact opposite of finding the derivative. So we're looking for the derivative over the original function form. So when we recognize that there is a derivative of function over the original function, we can just take the bottom of the fraction, which is the original function, and do the natural log absolute value of that, and that's the answer. So applying that to this problem, we're looking for the derivative over original form. And we can see that the derivative of the bottom, 3x, is 3, which is on top. So we have the form done perfectly. So we can just take the natural log of the bottom, which is the original function, 3x. And we forgot to write this, but there is a plus c, but that would be your final answer then.
Come on, Chelsea, find us a natural log. I don't think there's one over there. Oh, what is it? Thank you, Toby.
Oh my god, it's a natural log!
So for this example, we're going to be using the natural log at the end of the problem, but we're going to start by using the substitutions in the left-hand corner of the page, and then we're going to distribute the 2, and then we're going to split up the fraction and integrate the 2 pieces separately. And then after that, we're going to use the natural log form to integrate on the left side, and then just the basic integration with the exponents on the right side. And after we do that, we're going to substitute in the u for x minus 1. And after that, we forgot to add the plus c, but of course with integration, you always add the plus c at the end.
we're done finding the natural log for today. It wears you out a little bit, but I hope you learned a little something about the natural log and about how neat it can be.
Yep, stay neat, Eastridge.
Well, that's interesting how neat that is.